Okay, last section before the mid-chapter test. Section 4.4, trigonometric functions at any angle. It doesn't have to be just the two special 45, 90 or the 30, 60, 90, but we're going to work with different angles as we go through. So, we're going to use definitions of trigonometric functions of any angle. We're going to use signs of trigonometric functions to find reference angles and use reference angles to evaluate trig functions. So we got a lot of work to do in this section. So, first of all, definitions of trigonometric function of any angle. Let theta be any angle in the standard position of x, y. Be a point on the terminal side of theta. If r is equal to square root of x squared plus y squared is a distance from 0 to xy, the six trigonometric functions of theta are defined as follows. They still have to be right triangle. Sine of theta is y over r, x over r, tangents y over x, so on down the line. You could look at the formulas and tell you. Now over here, you'll notice that this is y cannot equal 0, x cannot equal 0, and y cannot equal 0, and that's mainly because of the fact that it's the denominator cannot equal 0 as you go through. So let point 1, -3 be a point on the terminal side of theta. Find that each of the six trigonometric functions. Now, if we know that x is 1 and y is 3, we know that r is equal to the square root of x squared plus y squared. So r is equal to the square root of 1 plus 9. -3 squared is 9. 1 squared is 1, which is the square root of 10. Now, if we do our six trigonometric functions, sine of theta, notice theta is all the ways around here, and we draw it back to the x-axis. Sine of theta is y over r, so it'll be a -3 over the square root of 10, which is a -3 square root of 10 over 10. Rationalizing it. Cosine of theta is x over r, so it'll be 1 over the square root of 10, which is square root of 10 over 10. Tangent of theta is y over x, -3 over 1, which is a -3. Cotangent is x over y, so it'll be a -1/3. Secant is the opposite of cosine, so I'm going to say square root of 10. And cosecant is the opposite of sine, which is negative square root of 10 over 3. So we can find our six trig functions this way. But I want you to understand that this is an angle from here all the way through. It's not like a small angle or anything. It's just all the ways around there. Okay, what's it here? We got a point. Let P be a point in the terminal side of the angle. Find the six trigonometric functions of theta. Well, we already found this. We already did this problem, so we don't need to do it again. And we already did that, so we're kind of done with that. Now, how about this? It says evaluate, if possible, the cosine function and the cosecant function at the following quadratic angle. Okay, if we drew this in, quadratic angle 0 degrees is right here. Well, if we think of this point here is 1, 0 on the unit circle. And now if we do x squared plus y squared equals r squared, we're going to get r is equal to 1. Now if we set up cosine of theta is equal to x over r. So x is 1, r is 1, so that's going to be 1. Now cosecant is going to be r over y. R is 1, y is 0. Can't do that, so does not exist. Undefined. So let's do this one. 90 degrees. Now let's draw 90 degrees out. 90 degrees is up here. 90 degrees is 0, positive 1. So it says find cosine. So cosine of theta here is x over r. Again, with this point here, we get 0, 1. My r is still going to be 1 when we do x squared plus y squared. So it'll be 0 over 1, which is 0. Now cosecant is r over y, which is 1 over 1, which is 1. Alright, so the cosecant does exist here. So 180. You notice I'm drawing these out. I always have to draw these out when I go through. I'll pick a point, 180. This point's going to be a negative 1 and 0. R, still go x squared plus y squared equals r squared, is going to be 1. R is always positive. Now if I want the cosine, x over r, negative 1 over 1, which is a negative 1. Cosecant is r over y, 1 over 0. Can happen, does not exist. And now the last one, 270. If I pick that point, I'm going to have 0, negative 1. R is going to be 1 again. Cosine of theta here is going to be x over r, 0 over 1, which is 0. And cosecant of theta is equal to r over y, which is 1 over a negative 1, which is a negative 1. Now, the things you know about the trig functions. It says in quadrant 1, all functions are positive. In quadrant 2, sine and cosecant are positive. In quadrant 3, tangent and cotangent are positive. In quadrant 4, cosine and secant are positive. Now I always remember this by all students take calculus. And first quadrant, all are positive. Second quadrant, sine and the one that goes with sine, cosecant is positive. Third quadrant, tangent and cotangent positive. Fourth, calculus, C, cosine and secant are positive, the one that goes with it. So now if we look at this, it says if the sine of theta is negative and cosine of theta is less than 0, name the quadrant which the angle lies. If both sine and cosine are negative, well, they're positive, sine's positive. Sine and cosine are both negative in this one, and cosine's positive here, so it has to be quadrant 3. And we're going to use some of these as we go through. Okay, given tangent of theta is equal to a negative 1/3 and cosine is less than 0, find sine theta and secant theta. Okay, so tangent of theta, we know that tangent of theta is equal to y over x. So one of these has to be negative. So we know that 1 and we know that 3. But one of them has to be negative. And we know that cosine is less than 0, so x has to be the negative one. Now we can figure out r. R is equal to x squared plus y squared, which means that it's square root of 10 when we work it out. X squared plus y squared. We know this is negative because cosine is negative. So now if we went through here and said, okay, we know our quadrants from sine. Sine of theta is y over r. So y over square root of 10, which is square root of 10 over 10. And secant of theta is equal to r over x, which is square root of 10 over negative 3. Okay, definition of a reference angle, and then kind of finishing up here. Let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle formed by the terminal side in the x-axis. So, okay, the reference angle is the angle formed when drawn back to the x-axis. So if I drew an angle here, this is my reference angle. If I drew this angle, draw a triangle back, that's my right. Draw a right triangle. That's not very right. That's my reference angle. It's one drawn back to the x-axis. So, find the reference angle for each of the following. 210. Okay, so if I drew 210 degrees out, 210 degrees is right here. So what I would do is say this is 180. 210's right here. My reference angle would be 210 minus 180, which is 30 degrees. My reference angle is 30 degrees. 7 pi over 4. Now 7 pi, some people might have to change this to degrees, but 7 pi over 4 is right over here because 8 pi over 4. Right here, 7 pi over 4 all the ways around here. Because 8 pi over 4 is 2 pi, which is a full circle. Now if I draw that back, here's 2 pi. Here's 7 pi over 4. So if I take 2 pi minus 7 pi over 4, I'm going to get pi over 4 as my reference angle. Now if I do a negative 240 for C here, negative 240, here's 180, 240's be up here. Negative 240. And my reference angle going back here, this is a negative 180. So if I want to find my reference angle, this is my reference angle. I would take a negative 180 minus a minus 240. I'm going to get a reference angle of 60 degrees. 3.6 radians. Well, 3.6, we know that pi is here, which is 3.14. So 3.6 has to be over here. My reference angle is down here. So we're going to take 3.6 minus 3.14. We're going to get 0.46 as my reference angle. So finding reference angles for angles greater than 360 and less than 360, we're going to do some subtracting. Find the positive angle less than 360 or 2 pi that is coterminal. Draw it in standard position and then draw the reference angle as you go. So let's look at a couple here. Here's 665 degrees. So we're going to take 665 minus 360 first, and we're going to get 305 degrees. There's a coterminal angle. Now we have to find the reference angle. Now the reference 305 is way over here. So if we say this is 360, this is 305, and if we subtract those, we're going to end up with 55 degrees. That's my reference angle. So if we have 15 pi over 4, and we're going to subtract 2 pi, so 8 pi over 4, we're going to get 6 pi over 4. Oh, 7 pi, sorry, can't subtract. 7 pi over 4. Now that's less, and we just did that reference angle a little bit ago, 7 pi over 4, where reference angle was pi over 4. So then over here we got negative 11 pi over 3. Now we have to add 8 pi over 3. 6 pi over 3. That's 2 pi, and we're going to get negative 5 pi over 3. And that's still negative, so we're going to add another 6 pi over 3. And we're going to get pi over 3. So my reference angle, since that's in the first quadrant, that's automatically my reference angle. So my reference angle there is pi over 3. So the values of trigonometric functions of any given angle theta are the same as the values of the trigonometric functions of the reference angle, except possibly for a sine. A function value of acute reference angle is always positive. However, the same function value of theta may be positive or negative. So when we look at it, we use reference angles to find them. So like sine 135, we wouldn't know. But if we drew 135 out, here's 135, my angle's right there, draw it back to the triangle, we're going to have a 45 degree reference angle. Well, what we know about a 45 is that the sides are 1, 1, and square root of 2. So now it says find sine. Well, sine of 135 is going to be equal to y over r. So y is 1. R is square root of 2. Now we have to be careful a little bit here because this one now is a negative 1 here, but we didn't have to use it on here. So this is equal to the square root of 2 over 2. Let's try this. Tangent of 5 pi over 4. Well, 5 pi over 4. And now that's a little harder. Here's 7, so 5 pi over 4 is over here. This is 4 pi, so my reference angle here is pi over 4, which is a 45 degree angle again. So this is 1, 1, and square root of 2. Now, but we have to be careful because in this quadrant, x and y are both negative. Now we want tangent of 5 pi over 4. Tangent of 5 pi over 4 is y over x, which is equal to negative 1 over negative 1, which is equal to 1 on this one. Let's try secant of negative pi over 6. So, negative pi over 6, reference angle. Well, secant is an even function, so therefore this is the same as a secant of pi over 6. So now we're in the first quadrant. And so that's my reference angle, is pi over 6. Now pi over 6 is 30 degrees, I believe. 180, yep, 30 degrees. So this is a 30 degree, or pi over 6. We know that opposite my 30 is 1. Hypotenuse 2. This is square root of 3. And we also know that all of them are positive in the first quadrant. But now what we have here is, oh, actually I'm going to go back. Let's delete this. I'm going to start this one over because I did it backwards. We know it's the same as that value, but where our angle is negative pi over 6 is down here. Should do it right. So this is a negative pi over 6, but it's a reference angle of pi over 6. So we're going to have 1 square root of 3 and 2, and still the same values, except this is going to be a negative 1. But we're going to do secant now of a negative pi over 6. What we know here is secant is r over x, so it would be 2 over the square root of 3, which is 2 square root of 3 over 3 as we go through here. So now on section 4.4, last section before the next test, what we want to do is look at some stuff here. And let's say we have you do page 548, showing all work. Let's do showing all work number 80. No calculator. Show me how do you get it. 80 and 93. Thank you.